Okay, so as you'll notice with this, you'll see me do this experiment a million times. Well, hopefully, anyways, you're passing it through the keyhole back to the system. But in reality, you want to play this a bit of Mario speedrun assisted. This is your task inside here. First level, this is where the first mushroom jump comes in, and he has to pull volt it over Bowser to get the Princess Peach. Friction, true north, magnetic north, polar north, given the shadow of this thing having some spin, some polygon, CPU, GPU, limitations, speed bases, it cracking open the PS2, and actually being able to figure out, well, if I do this way, not only is it benefit and useful this way, it's also benefit and useful that way. But maybe they knew speedrun, electrical engineering, maybe PlayStation knew that, but maybe they had a hardline speedrun or something that was quantum. Maybe they had glitch rules. You never know, really, given what energy is in here.
Welcome to iLectureOnline.
Is it
in this video,
number
we're going to explore
or a unit, again being the standard model, causally, A or B, ideal gas, in a field that I understand, Roblox.
Here we have a photon,
skid steer.
which
Hey, skid
approaches
steer.
an electron.
Hey, skid steer.
If it interacts with the electron, it will give the electron a bump. The electron will go off in one direction, and the photon will go off in another direction.
Kobe.
If the photon has a wavelength lambda before the collision, it will have a different wavelength after the collision.
You break down the facial expressions about this reality. Two conversations about the same line here. We're going to use the same word. 45 minutes pen throw. Just keep trying it until you find which one works best. The limit Mario's, okay, we're doing that. And inside of here, smashing the controller.
Phi is the relative angle for the photon after the collision. Theta
Do
gives
what I
you
want.
the angle of the direction.
I want people to
for the
understand
electron after the
this is
collision.
why playing Nintendo
Notice
is
that
cool.
the electron has an energy, h times the frequency, where h is the Planck's constant, and the momentum
Yes
of
and no,
photon
kind
is
of
the
maybe.
energy of the photon
They
divided by
are,
c,
but they're not
therefore
really.
it's hf over c. The energy after the collision for the photon will be h times f prime. Now f prime, that's not the
The
derivative.
metaverse on here, Mario's first level, and any field that you program that has this kind of index into it, any time eschatology, non-purity state to, like, I have silver, but it's not. Alright. Uranium in Chernobyl, obviously, or
assume that the
maybe the
electron
purity
will
wasn't
have
as clean on the line of Mario shell jump speed jumping it first few runs before they tighten that thing off into, like, regardless if you hit the speed run or not, you're still within the top 5 range. Button toggle switch, you're doing it. You did it, but you gave up right there at Bowser. Like, you didn't have the speed run, I'm turning it over, there's no way I can get it. I know the frame rate inside here of the bus, this one's done.
That's not really the momentum.
Well, maybe we can do things with that extra fast boost jump on Mario 2 here, given the mass of the unit inside of the value. I hijacked that bus right there.
For those who are interested, we can say that lambda is equal to 1 over the square root of 1 minus v squared over c squared. So that's where that lambda came from.
So that's
also
45. It's like, yep, clip it out, put it in there.
Between the rest
Print
mass
MIT
and the
now.
total energy of a particle is such that we have the momentum of the particle, p times the speed of light. We have the rest mass here. And notice that the total energy is the hypotenuse length of the rest mass energy plus the kinetic energy. And so we'll get into that a little bit more later as necessary. So what we're trying to find now is we're trying to find how much the wavelength will change. Basically, what we're looking for is we're looking for lambda sub naught minus lambda. We're looking for the difference. And actually, we're really looking for the change in the wavelength.
The program
of the photon
energy by wave function and calculus to the marshmallow experiment levels to success.
Prime, so to speak,
mice drinking Kool-Aid with acid in it because they get trapped in this box.
That is the longer wavelength after the collision minus the shorter wavelength. So how much
they just
is the
live in here in the empty
change?
order. They let all the other ones shoot through. They just hold them
Using
up
the
post.
conservation momentum. So we need to solve the conservation momentum in two directions: the x direction as well as the y direction.
All right.
So
well,
in the x
whoever's got
direction,
that mass to the
initial
Engling
momentum
angle
is
0.
only
I think
that
that's
of
what
the
that is.
photon. So we have
This is
P
mass
of the
0.
photon,
This
which
causal.
is
This is
HF
mu. right?
over
I think
c
is what that is. We
plus
might
the
be saying this
momentum
is
of the
omega.
electron, which will
I
be
don't
zero
know. It
because
might
it's
be v.
motionless before the collision.
Those are very, very
equals
important
the
numbers.
momentum
If
afterwards.
velocity is
For
squared,
the
and that
photon,
number
it's
should be
going
a
to be-
photon moving at
The momentum is going to be hf prime over
megahertz
c
on the black body
H
problem,
F
or
prime
eVs
over c
or
times the
FMAs. It was like, what do you
cosine
mean? They
of
are
the
ones
angle.
and
In this case,
zeros.
we use the
Usually
angle
within
phi.
those things, it
So it would
can't be
the
other things. Well, if
momentum
it's
of
miles
the
per hour,
photon
it's not
in the
photons.
x direction
Not
plus the
planets.
momentum
Usually they
of
don't
the
move that way unless it's
electron
real
in the
weird and
x
we already
direction.
know
We're
about
just
it.
going to
There's
use
that area.
P as the momentum of the
Some
electron
neutron
times
star,
the cosine
zombie neutron
of theta.
star.
In the y direction, we should end up
That's
with
the
a similar
interesting thing
equation.
about gravity, isn't
In
it?
the y direction,
And bonds here.
notice that there's
Brat
no
cat
momentum before the
give
collision, so
you
it would be 0
AUAX,
plus
give you
0
some value
equals.
that's still,
For the
I can
photon,
input
it will be,
what,
as before, it will be
now
H
because
F
decay
prime
states said
over
the
C,
whole
but in
range
this
of
case,
those
we want
things
the
might
y
have been
component,
set of
which
wave
is the
functions. And
sine
you're actually
of
saying,
the
well,
angle
I need
phi
sodium or
plus-
lithium or
oh, not plus,
something
it's
in
gonna
there
have
that
the
conducts
minus
the
because you
number
can see that
the way I
momentum
want,
of the
and it's
electron is
actually
negative
in the
direction,
wave function
so
of
it's
it.
minus the momentum
You
of
might need
the
it as lithium
electron
salt, or
times
right,
the
you know, you
sine
need to
of
put
the
it in
angle
lithium
theta,
in solution,
talking
and
about the
it's
y direction. So those are the two conservation of momentum equations for the
fine
collision between the
particulate
photon
state
and the
to
electron,
make
and
ceramic
in the
out
x
of it.
direction and in the y
You
direction.
know, in itself, it's just goo in a dish.
The next
But
thing we're going to do
its properties
is
in
we're
the
going
way
to
I want.
multiply
I want to fix out
both
that geometry that also
equations
fits the gravity
by
I
C,
need to do. You know,
because one
it's an
1
Apple
over C, we're going
phone
to get
or
rid of that.
car.
And we're going to square both equations.
And it would limit that to
Also,
just
I
that
think
field
what we
theory
wanna
and
do is
just
we
those
wanna
numbers,
solve
which I might
for
say, all right, I'll
this
start
variable
again. That
right
was one
here.
of the
So what we're
breaks
gonna
on
do
here,
is
and I
we're
said the
gonna move
values
this to
under
the
those
front,
things were a
turn the
photon.
equation around.
The
So let's
energy
write
in
it
the
like this.
value
First,
is
we're going to multiply everything by
this.
C.
The
and move the
MC is
terms
some of
around
those
a little bit.
values, the
So we end
mass
up
of
with
those things in
P
units.
times
This is
C
the
times
energy.
the
It
cosine
says
of
it's
theta. So we take this one right
fractalized in
here.
these fields that
And
grind
that
to
is going
all
to
its
be equal
subparts.
to this component
And
times C,
then
which
the optics
is
of that
HF.
thing colliding on a plate,
And when we bring this across,
copper,
it'll become
brass,
minus
lead, or
HF
just Murphy and the
prime
stone mill they
times the
clocked in.
cosine of phi. So it's a little bit more compact
Being the
that way.
photon at
Notice
that
we
scale
multiply everything by
would give
C,
me the masses
and
at
then
those
we
scales to then say,
isolated
okay,
this by itself.
one
This is gonna be
experiment
P
may not
times
be
C
the only
times the cosine of
faculty,
theta,
but also
and move this to the other side, becomes
it
negative, turn the
should
equation around. We'll do the
probability
same
at
with this
least
one here.
33 and a third
Move this over
times,
here,
1/3
multiply both
percentage
sides by
ability.
C,
They'll do
and
all
then
right if they know
P
that that's the
times C
experiment
times
that
the
they're doing.
sine of theta is equal to
The limits of
H
not understanding
F
that and
prime
going, okay, well,
times
I'd
the
survive a little
sine
bit longer
of
here than
theta.
others, and compromising not understanding that probably
Alright.
wouldn't make it
Now
in
what
that
we can
box.
do is square both sides. When we
Because
square
it would
both
tell you
sides,
to
we
do
get the
something
following.
different instead
We
of
get
adjust to the
P
factors
C
of what
quantity squared
normal would be or what
times the
timelines
cosine
adjust to.
square of theta equals, when we square this amount, we get the first term squared, HF squared, minus twice the product of these two, because there's a
Oh, I'm
minus
dead.
here, so
Oh,
minus
not dead
2
yet.
times
No, not hung into it
H
yet.
squared
The
F prime,
cruise ship
times the
cargo line
cosine
hadn't taken
of
off my
phi.
head quite yet.
and then we take this term squared, that would
Woo!
be plus the quantity
Scuttering right across the floor there.
HF prime squared times the cosine square of phi.
Woo!
We'll do the same with
Got
the
some
other
chart.
equation.